Today we'll be going over the basics of the Poisson distribution. The Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time and/or space. If these events occur with a known average rate and independently of the time since the event. So an example of this could be a restaurant receives 5 new customers per an hour. The average rate is 5 and the independent time frame is an hour. Because of this, we can see how the Poisson distribution isn't actually a curve, but it's individual data points. While you could model this as a curve, it would be incorrect, as the only time the Poisson distribution has values is for integer numbers such as 0, 1, 2, 3, 4, and so on. This is because you can't have 1.5 events occurring, while for other distributions, such as the normal events, you could perhaps have a value such as 180.5 centimeters. Here, you can only have an integer amount, as you can't have half an event. That is the reason why typically it is not modeled as a curve, but rather individual points. The only value or data you need for the Poisson distribution is the average number of events that happen in a given space of time. As we can see here, we have 3 examples of the Poisson distributions, A, B, and C. In A, the number of the given event happening is 1. So for example, in one day, only 1 telephone was sold. And then we have 4 here and 10 here. So here might be 4 new phone calls per hour for customers, and 10 might be the number of meals sold at a restaurant. And now here we can see the differences, with green being 10, blue being 4, and red being 1. Unlike distributions such as the normal, not all Poisson distributions have the exact same shape, whereas normal distributions have the same shapes, whether it's more stretched out or it's narrow and tall. Here we can see when the average event number is 1, it is completely different to when the average event number is 10. Here it actually kind of looks like the normal distribution, whereas here it has a sloping effect. As we can see, it having 0 events and it having 1 event is nearly equally likely. However, when it then goes to 2 events, it nearly halves the probability. And as you can see, a similar thing happens here when the average event is 4. As we can see, 3 and 4 have similar values, then it starts exponentially decreasing if we go to 2, 1, and 0, but it doesn't decrease just as much had we gone to 3, 4, 5, and 6.